Hello everyone, hope you're doing well. Today we are talking about uh, next topic of or next part of machine learning, and it is about deep learning. So let's get started. Okay, so we'll be covering foundations, some of the core concepts about deep learning and neural network and architecture, and of course some world impact as well. So let's understand that from where this neural network came into picture. Uh, So before we go deeper, I think let's spend some time on how this is kind of deep learning coming to picture. So from where it is evolving, right? So of course, AI is a high level, super high level layer that consists of everything, including machine learning, robotics, and many other things as well. And deep learning is a specialized part of machine learning. Machine learning is need not to be deep learning all the time, right? There are some easier use cases about some finding some patterns and things like that that may not involve deep learning. So machine learning is a kind of broader term where machines are learned from the patterns and data, and deep learning is a specialized form of that where you involve neural network to learn the patterns and predict. Okay, so as you can see that it's a subset of machine learning, and basically it is uses neural network as a foundation thing, and we'll understand that how neural network looks like. At a very high level, it is like it has hidden layers to I'll use some about term like that you will understand weight and biases to kind of learn the patterns and it predicts, right? So we'll introduce what those terms means in coming slides. So traditional ML is that we talk it which is like which is not deep learning, right? That generally is like you can do a lot of automation there, but the deep learning thing that you got to adjust some of those things, right? You need to adjust some of the parameters. We call it hyperparameters. So that comes into picture in deep learning. Okay, so how you can evolve some of the example, right? That how you can evolve from let's take and text examples, so from text to characters to words, phrases, meaning. So all that goes into the cycle of neural network. It could be for images, it could be for audio. So basically, that's when you go for deep learning. And yeah, we'll see some of those use cases and actually how this works under the hood at some level, right? On vision, speech, and language in coming slides. Okay, so now you may be thinking that this neural network is like, we have those in brains. How come it is fitting into AI world, right? So it is fitting because it is trying to learn the patterns the way our brain learn the pattern, right? When we are kid, we learn from the society, family, some of your childhood friends, and we develop some pattern, right? Like for example, if we see some dog and nobody told us it's a dog, will not able to tell it's a dog. So somebody in family, mother, father, relatives, they tell, hey, it's a dog. So we learn from that pattern, and next time when we see a dog, we say he's a dog, right? We don't see that any other animal. So that's how even AI learns. So for example, family and friends are the like, you can say they train us when we are small that it is a dog, it's a cat, and things like that. Like that, somebody has to do the job of training the model, and those somebody is basically the ML engineer, data science engineer, things like that. So they basically train the model that, hey, this is what it is, this is the pattern, so that model gets smart and it is capable of predicting when it sees some new input. Okay, and it does with the help of, for example, we have cell and axon and all that in our brains. Like that, we have inputs that we get. We have weight and biases, basically. For each kind of neuron we have different weights, and we also add a bias, so that we can adjust as needed. And of course activation functions, they give us for output. So here's the formula. So if we look at high level, right, weight and biases, basically they comes into picture, and you be able to predict. The number of layers can be many as per the requirements, and yeah, and you can decide. And there's something called hyperparameters. So those are like how it's like a configuration. You can make it in simpler words, right? That you configure your neural network based on the training, that okay, it is going to be bait and bias, so that it is getting closer to the finding, that hey, here is a pattern, right? So that it can predict from coming, like next new data is when it sees that. So at a high level, the AI, the neural network in the AI is tries to mimic how the brain works. Hence, the name is neural network. Okay. I think there is a little history on that, how it started in 50 years. It's not a new thing basically, but I think of course we know that now it was earlier pretty much there in labs or maybe research papers and academics, but now it is very much there in the practice and day to day. Maybe we start using it because the hardware got cheaper, the data got cheaper, so all that things put together made this ML things really, I would say, practical thing, not just academic thing, right? And of course, uh, the Gen AI era is a totally new thing that really made it more, I would say, mainstream. So yeah, it is as we can see, it is not a new thing. It's almost 70, almost 70 years back it started. So it's not a new thing, but it could not become mainstream like talking points in developers community. It was mostly for researchers and scientists for to do some academics and all that. But yeah, now it's really become because of those the technical devolution that happened. Uh, so that is that has led to all that. Okay, we'll move to the next one. That let's go to the core concepts. So essentially, neural network have input layers. We call it, I think, the previous example you have seen X1, X2, the input layers basically. Then you have a hidden layers. Hidden layers can be as minimal as one, as max as hundreds and thousands. And output layer is something that will give you output. You might have seen Gen AI maybe transformer architecture, right? How it is layered. So basically, it is also part of the DL as well. The Gen AI era is all that comes from a very fundamental concept of DL. And it has different activations, for to make it, to process it. Like ReLU could be one for to adding non-linearity into the training. Sigmoid can be used. TAN and softmax. Softmax you might have seen, basically pretty much used in Gen AI world, where you have a multi-class classifications, right? It tries to put that, and it goes with the highest probability and tell you the answer. So we will not be covering in deep today for transformer architecture, but maybe in coming time we can go with more detail on how this works. But I think at a high level you can understand that there are different kind of activation functions that helps us really train this. They stitch together that the three things that we're talking about. Okay. uh, yeah, so I think as we're talking that they add the non-linearity, and they help us to find different patterns and train the model, so that a model is able to predict when it faces a real world scenario, and then totally a new data, right? All that. Now in neural network, the two concepts which are pretty fundamental, right? One is post forward propagations, means you go from input to output, and backward propagation that go from output layer to input layer and adjust your weight and biases. So, we're talking about how the forward layers work, right? And again, neural network is kind of I would say divided into several different types that we will cover later, and they have slightly different way of handling that. But this is fundamental. Like input layer, you will pass the raw data. It could be pixel, could be text or anything of tabular data. Then hidden layer will basically compute their weight and biases. And initially, you can start with anything, and over time, using backward propagation, is try to adjust those weight and biases and make it closer to how the pattern looks like. And of course, output layer will predict it that here's the output for this particular thing that you're talking about. And of course, as many we're talking about hidden layers because they're not visible to the users. Input and output are basically you can make a judgment that here's the input I'm entering and here's the output. But hidden layer, as I said, hidden layer can be as many as maybe hundred and thousands, and as small as one, depending on the scenario. So for example, face detection, right? Detection can be more deeper things, so you can have maybe few maybe tens and hundreds, right? Or depending on the how deep it is, right? So that will help you to find a better pattern. So basically, hidden layers are, as more you add, of course, you got to balance between latency and all that. But as hidden layers, as much hidden layers you have, you will be able to learn a better patterns. That's the crux of it. Okay. So those really helps us on finding the patterns and learning the patterns. Now, why we need a back propagation? So, like for example, forward propagation help us to go from input to output, right? It, and give a, so it's like you can say that uh, it goes from, you adjust some weight and bias and output, right? And then output realize that, hey, this not the looks like we are very far from the actual output, right? Then we try to adjust to those weight and biases, and that's when the backward propagation comes into picture, that we try to adjust those weight and biases so that weight and biases are really closer to the closer to the real learning, right? So that's when this and gradient descent is something that the error, you can say that, means how far the real output is, the actual output is from the real, like basically the output from neural network is from the actual output, right? So you find a gap. That's when you use that, and accordingly you adjust your weight and biases, and you make your model really, I would say, powerful, right? So the other three major steps that you do during backward computation or back propagation, basically. Okay. Now, there, as technology is evolving, right? Even some of these, I would say, uh, concepts and algorithms are, goes into, I would say, they go into uh, evolutions, and some better and better things comes to picture, right? Which are more efficient and less competition, all that. So things like batch, uh, I would say, gradient descents, all that. There are a couple of more types, right? Depending on the cases, you find out that Atom is, I have myself used Atom, is really powerful, and it does a lot of things, and widely used optimizer, right? So they try to optimize the way you calculate all the weight and bias, and it basically try to, the goal is that we reduce the computation, so that we end up training the model with lesser computation, and save our time as well. That's the goal. So these optimizers really help us on achieving that. Now let's go into how this architecture kind of is stitching together, right? So there is a concept of like ANN, we call it artificial neural network. In that, there are categories like CNN, convolutional neural network, and there is of course RNN, a recurring neural network that we'll see later. So basically, convolutional neural network are used for any kind of a picture and videos, like where you have a good kind of architecture detecting patterns in the images. All that is it is used, while the regular one, it does, like you can call it regular ANN, which is used typically for text and maybe for numbers. But for any images and all that, visual way, I think CNN is really good, because it uses some of those, the way it kind of calculates is really, is goes like step by step and like in tabular form, right? So it is more efficient, and it takes a less computation if you use n and there. So CNN are introduced with that. They're connected layers and all. So they use the matrix based, I would say, input mechanism, and they goes like, for example, there is an image, so it goes like this and learn the pattern, right? So CNN is more powerful for image based thing. It could be for imaging, for medical field, it could be for facial recognition, and even for autonomous vehicle art also, right? They need to detect the object in the when you drive. So it is really powerful on those aspect. Okay. Now, again, the innovation doesn't just stop, right? So RNN is a recurring neural network which is used for more of the advanced concept, and where you need to maintain the sequencing as well, that ordering of the data, or maybe it could be patterns in terms of, it could be, for example, you're talking about time series kind of data where you can't just have any random model, so you got to maintain the context as well, right? All that scenarios come into RNN when and you kind of train in a recurring way, and that's when the competition is kind of used more. But I think the uses of it is really phenomenal. You use it for speech recognitions, stock prediction, because you can maintain uh, the sequencing of it, ordering of the data, right? It is really important for this one. While in the previous one, CNN and RNN, CNN and ANN, you can live without much of the ordering data. But here, ordering really matters, and hence, context is really important. So you use the RNN for that. Okay, the goal is that, when you need to maintain the context, means the order, right? You also need to have a better memory so that you remember, right? That's when they try to solve with LSTM, long short term memory network, which having some gates and things like that. So they try to, I would say, adjust it. But again, now we are in a world of, I would say, transformer architecture that even does better, right? But I think this how this evolved. So RN, of course, there then LSTM came to have a better contextual memory over there. Again, it has not cracked to all the scenarios. That's when this in 2022, this transformer architecture really kind of changed the game, right? Because the way it calculates attention and things like that is really different, or dramatically different from the one that earlier it was happening. So LSTM is there. There are some other things came as well before transformer architecture, but I think LSTM is one of the important one uh, that kind of use that. Even GRU is also kind of used, right? So they try to, I would say, improve it as a step by step. But transformer architecture really changed the game. It is like a, dramatically changed the way it is kind of it does the attention based mechanism and learning, and it is really powerful in keeping the context alive. But again, we should know that there is a limit always, right? We can't store the forever memory, right? So there has to be a limit, because end of the day it is cost as well, because contextual memory is not cheap, right? It's costly. So you got to decide that how long you want to retain it. That's when nowadays we talk about token saving and things like that, right? If they really want to have a lot of like very long history maintained, you got to spend a lot of dollar or rupees in terms of token cost, right? So the point we are talking here is that whether the platform supports that. So yeah, nowadays we are living in the transformer architecture world, like GenAI thing, right? That does support pretty much long, you can say, memory. It can keep a lot of context data, but that came after we gone through this evolution over time, like RNN, LSTM, and GRU. Then of course now we are in that world. Okay. So that's what I was talking about, transformer architecture, right? The architecture behind ChatGPT, that was, I would say, game changer when it came. Okay. Again, if you're interested on how this works, go through this paper. Attention is all you need. Waswani and all, right? So I have gone through at a high level. It's really it explains you that what was the I would say intention behind it, how it tried to simplify it, how it kind of learning the attention and things like that. It's pretty comprehensive paper. And I think one session alone can be dedicated just for how this works. And again, there are classes, right, that happens for. So there's a lot of detail in there. There's a lot of concepts that is used in attention mechanism, right? And you first need to understand the basics of it before you understand that. But I think it's really good paper if you want to understand what is a algo theorem approach behind this chat GPT era that we are in right now. And of course, all other models, right? Not just GPT, but even Claude, BERT, Gemini, all that are behind the scene. It is sitting this transform architecture. Of course, they have tweaked it a bit depending on their individual use cases, but the backbone is still transformer architecture. Okay, and you might be wondering that what dramatically it does. So in the previous one, right, until the LSTM, we were maintaining that context memory. We increased maybe the memory size, but the processing was still sequential, right? So sequential processing is still how much you can go. There is always a limit. So transform architecture basically does this parallel training without losing the ordering of the data. They have different mechanism on how they. So it's pretty interesting to learn that how they keep uh, the ordering of the data, right? How they maintain that. But I think in short, you can understand that the parallel computation concept was introduced by this transformer architecture, and really phenomenal, really powerful, that powers the today's Gen AI systems, right? So if you're really interested, I think you should read this paper, that how this works and how they're able to maintain this parallel uh, computation thing using transformer architecture. Okay. So the concept, of course, you should be learning self-attention, how the each token is dependent on other tokens, and positional encoding, of course, is a backbone behind this, how they are able to maintain sequence. Multi-header attention, so how different type of relationship you can identify, not just one type, right? And feed forward, of course, how it is connecting to the one to the other, and how it is predicting. It's really interesting way to understand how this works. Okay, now I think we are towards the end of the session. So let's understand as how deep learning is really helping the industries and the real world uh, operations, right? So it is really in the game, as we were talking about earlier, right? That it could be about medical imaging, it could be about autonomous vehicles, biometrics, it could be any other retail and finance, and any field that you can think about, agriculture, entertainment, all that, right? So everywhere it is touching their operations, basically. It could be for fraud detection, it could be for finding out yield predictions, it could be about this we have seen a lot in Netflix and other areas, how they're able to find the recommendations. It could be about anything in finance. So it is really kind of changed the way that industries are operating. We have gone far from having a regular chatbot which kind of only understand keywords, to the intent based bots. You will write something, uh, they are not just depend on the what you write, but what you wish to write, right? What is your intent behind it? So they figure it out intent from the few words that you put, right? Earlier, if you want to say something, uh, if they can read the English and they will try to translate it, but if you put something in sarcastic way, they will not understand because they just know the pure English. But today's system using Gen AI, they really understand your sarcasm as well, because if you say something sarcastic, you mean different, but you were writing different, right? So they are so powerful that they understand your intent. They're trained in with so many data, so much, millions and parameters nowadays, even billions, right? So uh, they understand that there is a plain text, you can read the face value, or there is some sarcasm behind it, or you mean something else. So we have really gone a far, a long way from those regular chatbots to the AI based chatbots. So it has really changed the way how industries are functioning. And and thanks to the deep learning and neural network behind the back as a backbone to support the tech that we are right now in. Okay. Again, it is only going to grow, folks, because we have not yet, even we are using Gen AI a lot, we have just touched the surface, right? There's more deeper, there are more areas, it is yet to be explored. So it is only going to grow from here. Of course, we need to be powerful about the safety aspect, the responsibility aspect, all that responsible AI principle that nowadays really become important to avoid misuse, to avoid abuse, all that is important. But the opportunities are immense, and it is only going to grow if we use in the right way. It is only going to help us. Okay. With that, some of the challenges that we should be aware about. I think I did touch upon few, but I think we can understand that, and how we are trying to deal with those, right? Because every challenges also bring us some opportunities. It could be about uh, multimodal AI, edge AI, sitting there to minimize the cost. Multimodal can be good for data hunger, like a lot of data is getting consumed. Uh, Mixture of expert is used for having the minimizing the bias and fairness, all that. So basically, there's some approaches nowadays, which are really kind of helping to find a way out the challenges which are there. But again, these approaches are still not completely, I would say, evolved. They are in an early stage, and there is a long way to go to them to get matured. But I think more and more solutions are coming forward to address some of the challenges which are AI is putting us into, uh, in day-to-day operations and uses. So watch out these advanced emerging trends which are going to be helpful and in your individual use cases. Okay, with that, we are done. Thanks for your time, and see you some other time. Start using and make it. I would say start getting benefit of it. Thank you.